Calculus! All right, here we are in AP Calculus AB. We are on self-check 4.1. Here are the answers. Answer to number 1 is E. Answer to number 2 is, wait, that's not E. It's D. Sorry about that. It's D. Haha, I tricked you, and you maybe fell for it. Correct answer to 2 is D. Correct answer to number 3 is E. Correct answer to number 4 is, I don't remember. Let's go look at the key. It's B.
Guess right.
All right, which problems do you want me to go over?
2, definitely. Yeah, 2.
Do you want to see number 1 at all?
Yeah.
You want to see number 1? Okay. Mean value theorem. What is the mean value theorem?
You need to find the slope.
What is, yeah, so you do need to find the slope, but what does mean value theorem state? That f prime of something is equal to something, something, something.
Average rate of change.
I need the formula.
F of B minus F of A over B minus A.
All over b minus a. That's the right-hand side. What's the left-hand side? F prime of c. There it is. There's our definition of mean value theorem. So I'm going to take the derivative over here. That's going to be 3, and then instead of putting an x, I'm going to plug in a c. So it's going to be 3c squared minus 4c. That needs to be equal to f of b. So b is 2, a is 1, or a is 0, sorry. So that means f of b, I'm plugging in 2 in here. That's going to be 8. When I plug in 2 here, it's going to be 4 times 2, which is going to be 8. 8 minus 8, that's going to be 0 for f of b, minus f of a. So when I plug in 0 here, it's going to be 0 minus 0. It's 0 again, and as long as the bottom is not 0, let's just check that the bottom is not 0. It's going to be 2. So I need this thing equal to 0. So I'm going to factor out a c, or yeah, that's the best way to do it. C times 3c minus 4 needs to be equal to 0. From there, I know that means that c is equal, c is equal to 0, or c is equal to 4/3. 0 is an endpoint. Don't worry about him. It is 4/3. Correct answer, D.
I'm not gonna lie, I didn't do all of that work, but I still got it right.
Okay. Yeah, so 0, that's an endpoint. We don't know if it's differentiable on 0. We're looking for somewhere between 0 and 2, and that number is 4/3, which is 1.333 repeating. Therefore, it's between 0 and 2. Questions on number 1? Number 2, I know that we have questions. All right, we have a circle increasing. What do we know about circles? Circle circumference is equal to
2 pi r.
2 pi r. List everything that we know. Area is equal to something.
2, pi r squared.
Pi r squared. Okay, we have those things memorized. They have to be memorized. Let's read the rest of the problem. At a certain instance, the rate of the increase, rate of area, that's talking about A prime here. So let's talk about A prime. What did it tell us? A prime is numerically equal to twice the rate of the circumference. So the rate of circumference, that there is C prime. So this, if I'm making a statement, A prime, if you ever see the word is, it means equal. A prime equals 2, because twice, 2 times C prime. A prime equals, A prime is 2 times C prime. What is the radius of the circle at that instant? Okay, well, we have A prime and C prime. Let's go ahead and find A prime and C prime again if we didn't know that. C prime is equal to, shout it out someone. C prime is
2 pi r prime.
2 pi, close. It's not r prime.
To the r to the first root.
Just, yep, r prime. And then A prime is equal to
That one would be 2 pi r.
2 pi r prime. So go ahead and set those equal to one another, and then we have 2 pi r prime needs to be set equal to 2. Then there's my C prime, which is 2 pi r prime. We're looking for the radius. So we're solving for r. R is our unknown. Let's go ahead and label that up here. We're looking for r. R is our question mark, our box, our empty value that we don't know. So I'm going to divide both sides by r prime. Bloop, bloop. R primes are gone. I'm going to divide both sides by 2. Bloop, bloop. There they are. Divide both sides by pi. Bloop, bloop. There they are. I'm left with just 2 on this side. I'm left with just r on that side. R is equal to 2. Questions?
Couldn't it be just better if we just divided 2 pi to both?
Yep, you could divide 2 pi r prime on both sides. That is exactly what I did in one condensed step of Mr. Sandell's 3 steps. All right, we're on to number 3. Questions about number 3? Nope. Ben, no. Rochelle. Ben, did you get it? E?
Yeah.
All right, so no questions then? If you guessed on it, I can still go through it though. Nope. Okay, number 4.
I guess on that one.
You guessed on number 4, so we're going to go through it. So we have a right triangle. As soon as I know I'm a triangle problem, I am immediately going to what?
Draw a triangle.
Draw a triangle.
Right triangle.
And draw a right triangle. Does it matter west, south? No, I'm just going to draw a random triangle. There we are. Boom. All right. Leg AB. I'm going to randomly label this. It might be not to scale, but I'm going to go A, B, C like that. Leg AB is decreasing at a rate of 3 centimeters per minute, so I'm going to put a -3 in red here. If you're you can do something like an underline or something to let you know that it's the rate if you want, or you can say something about this is the prime that you're looking for, the derivative. I don't know what you want to do for your notation. For me, I'm doing color-coded.
It never matters where you put it, right? How you label the triangle.
It matters if you are talking about the rate or the length. This is not the length, obviously. You can't have a negative length here. So it just matters the difference between a length versus a rate. This is a rate. Rate of 3 centimeters.
Says how is the hypotenuse BC? So BC, how you labeled it.
Oh, it does matter how I label it then. So that means AB.
A should be where B is. And B should
Yeah, I
be
need to
where
switch those two. Yep, good catch. Let's come back here
If
and.
it doesn't tell you, it doesn't matter, right?
If it didn't tell you, yeah, you can label however you want. Oop, come on now. So AB is -3. Next, leg AC is increasing at a constant rate of 4. So I'm going to label this in red 4. How is hypotenuse BC changing? So that's our question mark right there. When AB is equal to 12, so AB, that's going to be 12 right here. And it tells me that AC right here is 5. Oh, you know this Pythagorean triple. 12, 5, and
13.
there it is. You need to have that memorized. 12, 5, and 13. If you don't have that memorized, you can do it the long way of a squared plus b squared equals to c squared. 144 plus 25 is 169. 13 is the square root of 169. All right, so we have all of the piece of information because there's a total of 6 variables. One of them here is unknown, therefore we can solve for it. Here we go. Our original equation is a prime plus b prime is equal to c prime. We can fill in a ton of these. First I'm just going to randomly decide that this side is a, that side is b, and that side is c. It doesn't really matter because legs are just going to be added up. There's a commutative property of addition. It doesn't matter. So I'm going to say that this is going to be 5 times 4. 5 times 4 there, and then I'm going to add that to 12 times -3 times -3, and that's going to be equal to 13 times this unknown c prime. All right, 5 times 4 is 20. 12 times -3 is -36. This is equal to 13 c prime still. That's going to be a -16. Then I'm going to divide by 13 is equal to c prime, and our units are going to be centimeters per minute, 16 over 13, and it's decreasing because it's a negative rate. There it is. Questions? No questions? All right.